All right, I want to document something here. I've got my voltmeter hooked up and this capacitance meter hooked up to this cell right here, which is inactive. You can see the capacitance is in the microfarad range, and we got millivolts across the cell. This cell here is active, and what I'm going to do is switch out this voltmeter and capacitance meter over to this one just as soon as I unplug it to test the values of it. You can see millivolts and microfarads. Hold on. Alright, now I've connected them up to there, and you will see instantly we got voltage, and we are in the pico farad range here, and you can see that number right about 4.6, and that voltage is still going down as a capacitor should be discharging. But as that voltage goes down, the capacitance will go up. And there's a threshold here that we reach where this thing just pukes and goes back to the microfarad range. We're going to keep recording it here. Picofarads going up. Extremely at 1 volt. Look at that. Capacitance changes tremendously.
In this series of videos, I document my progress on unlocking the secrets of Stanley A. Meyer. For over a decade, I've studied and replicated the devices of Stanley Meyer, specifically the water fuel cell, a device that splits water into hydrogen and oxygen for use as a combustible fuel. Here, I discuss water fuel cell theory in hopes of connecting with other like-minded individuals to unlock the secrets. This is Stan's Revenge.
Extremely at 1 volt. Look at that. Capacitance changes tremendously. So it seems like once we go over that 1 volt, the fields collapse inside of this thing and no longer has the same capacitance as it does when it is active. Again, to my theory that when these cells are designed, people measure the capacitance of these things at idle and think that's the capacitance of the cell, when reality is the capacitance is measured while the device is active, or while these tubes are still energized, while they still have power and capacitance to them. As we saw here, when we had voltage, we still had a very tiny capacitance in the picofarads. Now that with no voltage on the cell, we are in the microfarad range again. So I've noticed this before. I wanted to document it this time. This appears to be 100% correct, and we need to tune our circuit for the lower picofarad range, because that's going to be what these cells actually operate at. Those are my findings. Alright, part 3 of our endeavor here. We have our cell producing, and we're going to switch these leads out and test our values. Alright, we've got our leads separated here. Immediately we can see we are in the picofarad range, and as voltage continues to plunge, the farad range keeps getting larger, kind of bouncing around a little bit, but you will see ultimately it does grow. I think once it hits about 1 volt, it's going to do the same thing and basically tank the circuit. Interesting how this one does appear to be holding out longer than the other one appeared to. Here we go, breakdown. Look at that, down to millivolts instantly. It skipped like a whole 800 millivolts. There you go, back in the microfarads. Point proven. We go from microfarad to picofarad when the cell is active. Alright, we changed out our water in here with some nice fresh tap water. No electrolyzer, nothing like that, fresh tap water. Did drastically change our amp consumption because we had to adjust to a different frequency to get the highest voltage. We were somewhere, I think, was it 3 kilohertz? We're down to less than 1 kilohertz with regular tap water, which means the properties of this change drastically as the contaminants in the water or the water gets saturated with contaminants rather. So we are going to look at this further and see if we can tune it even better.
This is Stan's Revenge.